Great. Sorry about the short interlude. Our next speaker is Richard Hawkins from the AIP University of York. I worked with Richard for a couple of years, and it's a great pleasure to do so. So it's really good to have Richard here today. Thank you.
Okay, thanks. Thank you for inviting me. It's good to be here and with such illustrious company. So hopefully I can talk about some interesting things from my perspective. So improving safety case practice with GSN. So what I was really trying to talk about here, so that there has been lots of criticisms over the years of safety cases and the safety cases approach to doing safety assurance. And I'll talk about what some of those are shortly. And obviously many people within the community have kind of responded to those criticisms. And a lot of the criticisms that are made, the response that's given is often along the lines of, oh, but that's not actually how safety cases are supposed to be done. Yeah, so that's not how they're supposed to work. So I think really what this is saying is that perhaps we should be doing more to help people to use safety cases in the right way, okay, so that they are used more effectively and used in the way that they're intended to be used, and hopefully see off some of these criticisms that have been made. So what I'm going to talk about today, so as I said, first of all, just a very quick summary of what some of these criticisms are that have been made. And then I'm going to look at some of the tools that we have to address this. So one of the things that I want to try and get across today is that I don't think we need to invent lots of new stuff in order to address this. I think we've already, and I'll talk about GSN, I think GSN already provides us with the tools that we need to do this. And I think maybe what we need to think about is how do we use those tools more effectively? So I'll go on to look at how we could do that. And then I'll finish up with an example of how I think this can be done. Okay. And you'll see as I go through this, I'm actually going to be picking up some of the themes that Robin's already talked about and looking at how we can use those. Okay, so criticisms of safety cases. So there's been quite a few things said about this. So I'm not going to try and do an exhaustive survey. I'm going to try and pick out some of the highlights and summarize what they are. And I think the only place we can really start with this is by looking at some of the things that have come out of from Nancy Leveson. So for those of you who haven't come across Nancy Leveson before, so she's a professor at MIT in the US. Very respected figure in safety engineering. So things that she says, people take notice of, and she's very influential. So it is important that we take her criticism seriously. And she's written quite a few things on this topic. I focused on this one, which is a white paper that she wrote, Limitations of Safety Assurance in GSN, and just pick out some of the key messages that she was trying to get across in this. So the first thing that she talks about is this idea of after the fact assurance. And these are quotes from her from this paper. So she says, system properties such as safety must be built into the system from the beginning. It's not possible to assure a completed system has a particular property without using a flawed argument when it doesn't actually have it. Now, I think we'd all agree with that. It'd be very hard not to agree with that, okay? She then goes on to talk about these two ways in which we might assure a system is safe. So one is to perform after the fact assurance, or the second one is to assure the system is safe as it's being constructed. Okay, and then she says for one, a system's constructed and then assurance and certification are based on an analysis. The already constructed system will be acceptably safe in terms of safety. Okay. Now, again, I don't think there's anything wrong with what she said there, but of course the implication she's making is that safety cases are number one. Okay, so her point is that safety cases by their very nature are after the fact assurance. Okay, now I think most of us know that that isn't really what safety cases should be. So safety cases should be used to assure the system as it's being constructed. So we need to make sure that the way in which we're doing safety cases is like that. Now, I know there's lots of pockets of very good practice where probably number two is being done. But I think in general, there is also a lot of safety case practice that, to be fair to Professor Leveson, probably does look much more like number one still today. Okay, and I think this is potentially one of the issues. Okay, so what else did she say? The other big thing that she talks about is confirmation bias. So she has a lot to say about this. Okay, so confirmation bias, a tendency to interpret new evidence as confirmation of one's existing beliefs or theories. So if the goal is to show something safe, people tend to look for data that will support that goal. So, i.e. an argument the system as designed is safe, paying more attention to information that satisfies the biases, whilst at the same time ignoring information that contradicts that goal. And then she goes on to say, so how can we overcome confirmation bias? One way is to look for ways to challenge your goal, not to achieve it. For example, look for arguments the system is not safe, rather than arguments that it is safe. So that's quite interesting. So she's actually proposing a solution for us there, okay, which is one of the things I'd like to pick up on. So she goes on to say, making an argument for safety is always subject to confirmation bias, and instead you need to focus on gathering evidence that the system's unsafe, actually seeking out and consider contradictory evidence. That's the standard process used in hazard analysis. Okay, so I think it's good she's suggesting a solution here, and I think we can do this. And I think we can do this with existing tools that we have. And I'll come on to talk about how I think we can do that in a second. Okay, so moving on from Nancy Leveson, I'm just going to look at one other place where there's been some kind of high profile criticisms or challenges put forward regarding safety cases. So most of you, I'm sure, are familiar with the Nimrod review. So the review into the accident where the Nimrod crashed, killing 14 people in 2006. And there was a very extensive review done by Charles Haddon Cave. And it had a lot of things to say. It had some very interesting things to say about safety cases. So I'll just pick out some of the, again, some of the kind of main messages here. So one of the things he talks about is this idea of a paperwork exercise. So the Nimrod safety case was a lamentable job, riddled with errors. It was essentially a paperwork exercise, virtually worthless as a safety tool. The defining features of the production of it are high level of incompetence, complacency, and cynicism by the organization. And he also talks about confirmation bias. So there was a widespread flawed assumption that the Nimrod was safe anyway, and this fatally undermined the safety case process. Okay, and I think these are essentially echoes of what Nancy Leveson also said. Okay, where the safety case is being used not as a tool to increase safety, but just something that's produced after the fact to satisfy people that you've done it. And this idea again comes up with confirmation bias. So the Nimrod report also goes on to make recommendations, lots of recommendations, some of these relating to safety cases as well. Safety cases should be renamed risk cases. We won't worry too much about that. But this to focus attention on the fact they're about managing risk, not assuming safety. Okay. It does say safety cases have a useful role. So properly aligned, safety cases should encourage people to think as actively as they can to reduce risks. So this is good. So what he wasn't saying was we shouldn't use safety cases. He's saying safety cases actually, if they're used properly, can be a really good tool to help make systems safe. What he's essentially saying is that they're not being used right, they're not being used well, and they're not achieving the purpose they set out to do. And then we've got specific things that he says about GSN and CAE. So tools for structured arguments such as GSN or CAE should be used with care to avoid falling into a trap of assuming conclusions such as the platform is safe, or looking for supporting evidence for the conclusion instead of carrying out a proper analysis of risk. Okay. So Haddon Caves essentially set out a challenge to the community there. So I think it was 2008 when the report was issued. So we've had 15 years since the report came out. And I guess the challenge is, have we significantly improved safety case practice? As I said, there's some pockets of really good practice, but I think in general, have we really moved on in the way that Haddon Cave wanted us to as a community? And you can think about that for yourselves, I guess. Okay, so that's kind of what we're trying to address here. So I'd like to move on now and think about what we can do to try and make things better. Okay. So lots of people have thought about this, how we can improve safety case practice. So one of the things I've noticed when people have done this, often the way in which they'll try and address this is they'll often do things like proposing whole new notations as a way to deal with this. And I'm going to show you an example of where this has been done shortly, so you can see what I'm talking about. And my position is I don't actually think that's necessary. As I've already said, I think we already have the tools to do this. So GSN has tools that can address these problems. I don't think we need to invent a load of new stuff to do it, but we do need to start to use those existing tools more effectively. And the kind of tools I'm talking about, I'm going to look at those in a second. These are all defined in the latest version of GSN standard, which produced by the Safety Critical Systems Club. So this is all stuff that's established techniques that we can use. Okay. Right, so I'm going to talk about two things in particular, part of GSN, that I think we need to make better use of. So the first one is dialectics. So for those of you who aren't familiar with this, how this is done in GSN, I'll just very quickly. So this is an example taken from the Safety Critical Systems Club assurance case guidance document using the GSN notation that's described in the standard. So the bit in the middle here, this is our, if you like, our standard GSN argument that claim that all threats have been identified, an argument over using a structured brainstorm, and a claim that the brainstorm has been controlled by keywords and that all the threats are recorded in a threat register, and then some evidence to support those. And the idea with the dialectic notation is that it allows people to then come along and look at that argument and make challenges to it, ways in which they think that might not be true. And in this example, for example, we've got someone who's come along here, so the dotted arrows represent challenges, and you can challenge any element in the argument structure. So here someone's come along and reviewed this and said, I'm making a challenge here because I don't believe that a structured brainstorm is a good approach. So they make a claim that challenges the argument, says a structured brainstorm is not a good approach, and they can support that with some evidence to show why they think that. And then this dialectic is a kind of iterative process. So the developer of the argument could come along and say, actually, I can rebut that challenge, because actually structured brainstorms are recommended by the standards as good practice when we're doing threat analysis, and I've got some evidence for that if you go and look in the standards. So they're making a challenge to the challenge, and then the cross through there means that that challenge has been defeated. Okay, so we're managing to record that dialectic challenge, counter challenge. And then here we've got a challenge through some evidence. So the claim that all threats have been identified, well, someone's found a threat that wasn't in the register, and that's a direct challenge to that claim. So that counter evidence represented here. And again, the person responsible for this argument can challenge that and say, well, that's not a realistic threat given the operating environment. And again, they defeat that challenge. Okay, so that's dialectics. So that's one of the tools that we can potentially make use of. Another aspect of the notation is the idea of having confidence arguments. So what we're interested in here is thinking about safety cases essentially having two kinds of arguments in it. So there's arguments which are about risk mitigation, which often form the central core of an argument. But then there's lots of other arguments that we need to make about why we have confidence in that risk argument. And the idea with having confidence arguments is that you separate arguments about the risk from arguments about confidence and why you have trust in those claims. And the mechanism that's provided in GSM for doing that is what's called assurance claim points. And we can see those 3 assurance claim points here. Okay, and each of those assurance claim points means we made a confidence argument about that aspect of the main risk argument. And then again, this is taken from the standard, the form in which we might make that confidence argument might be that we have some support for why we believe that claim is true. And then we might think about ways in which it might be untrue and show that that's acceptable. Okay, so we're happy that those uncertainties that are left aren't reducing our overall confidence in the claim that we're trying to make. Okay. So this idea is that it makes it easier for people to see the main thrust of the argument, but they can still see these confidence arguments that sit around that if they need to. Again, this is all defined in the GSM standard. Okay. We're going to come back to these shortly. I'd like to just take a little divergence first. So I talked about people trying to introduce new notations to deal with some of these challenges. And I'd like to show you an example of the kind of thing that I'm talking about here. So this is a paper I found really interesting. It's quite recent. So it's published this year. This is for the Journal for the International System Safety Society in the US. Some quite well-known names as authors of this. And this paper, so they called it incremental assurance through eliminative argumentation. And what they're essentially trying to do here is to construct an argument that the claim that they're making is untrue. Okay. And then what they're doing is then incrementally building up assurance by collecting evidence to disprove those defeaters that they've put forward in the argument. Okay, and you can see on the right how they represent this. Okay, and essentially this is a completely new notation that they've invented in order to do this. I'll look at this in a little bit more detail just so that we can see what they've tried to do here. So this is largely based around what they call inference rules and defeaters. So they've got a claim at the top here. This is the example they use. It'll snow in Vancouver tomorrow. And look at what their strategy is. It's to argue over reasons that it might not snow. So they've inverted the claim, and their strategy is to argue over reasons why that might not be true. They've got this inference rule here, which says that if there's sufficient moisture and it's cold enough, it's likely to snow. But then they've identified these explicit defeater claims, essentially, which is that will be true unless there's insufficient moisture or unless the temperature will be above freezing. Okay, so it's completely switching around the way in which we'd normally try and make these kinds of arguments. And then what they do is they then go out and look for evidence that shows that these defeaters don't hold, such as they've gone and got these models that show that a cold front will move through Vancouver tomorrow, and therefore that defeater doesn't exist. So this is that idea of incremental assurance comes from, is that until you can show that all of these defeaters aren't true, you haven't got a valid safety case. And they have these residual doubts here where defeaters that they're not sure how they can get rid of. So I think this is really, really interesting. I like this idea of, well, actually, let's try and prove it's not true rather than prove it's true. And going back to things like Haddon Cave, it's the kind of thing he was asking us to do. But I'd like to show you that I don't think we need to introduce a complicated notation like this. I think we can actually already do this. It's just that we don't do it. And I'd like to try and convince you that that is the case. Okay. So I'm okay. Good. So what I'm going to do is essentially take this example, not because I think it's a brilliant safety case example, but I want to show you how this same thing can be achieved using GSM that we already know and love. Okay. So let's start with the basics. So if we wanted to make this argument, what would we do? Well, we same top level claim. It will snow in Vancouver tomorrow. And we need a strategy for how we're going to support that. So we're going to make an argument over the presence of the necessary weather conditions. And we've got some context here that this describes what those necessary weather conditions are, which are that it's both sufficiently cold and sufficiently moist. And then the way in which we're going to argue that is two claims. Firstly, that there's a storm over the Pacific Ocean predicted to arrive in Vancouver tomorrow. And we've got some evidence for that from satellite imagery of the Pacific. And we've got a claim that there's a cold front moving through Vancouver tomorrow as well. And we got some evidence from weather models for Vancouver to support that. Okay. So kind of, current practice around safety cases would get us this far, but perhaps we'd be tempted to stop at that point. Okay, we look at current guidance on what to do. And I think what I'd like to show is that we should go further than this. Okay, so we need to kind of do a bit more than this. And I think the first thing that we need to do as developers is take this structure and think about how might this be defeated. So how might we challenge that argument that we put forward? And we've got the notation to do this. So we've talked about the dialectic notation earlier. So as a developer, I should be, as well as developing this argument, thinking about, well, how would I show that that was untrue? And not leaving that to a review process at the end, but actually doing that as part of the development process itself. Okay, so we've got our strategy here, an argument over the weather conditions. Well, I could challenge that by saying, actually, those weather conditions that have been predicted, they might not actually be sufficient for snow at all. Okay, that's a reasonable challenge that we might expect could be made to our argument. We've got some evidence here that based on these weather models, well, thinking about actually, someone could easily say that the models aren't reliable as a way of forecasting freezing temperatures. So there's potentially a challenge that could be made there. And then we've got this claim here about this storm over the Pacific that's going to arrive. Well, actually, there's multiple things I might be able to challenge here. Potentially, the wind could change direction before tomorrow. But also, the storm might lose quite a lot of energy as it passes over the landmass on its way in. Okay. So just to emphasize, the key point about this is that these challenges should be made by the people developing the safety case, okay, at the time at which the safety case is made. And what that allows us to then do is to, as developers of the safety case, think about how we can mitigate these challenges and then actually incorporate that into the argument itself. Okay, so as we're developing the argument, we're thinking about how it might be defeated and then implementing those mitigations into the argument. And this helps us to address two key things. So it's encouraging people to think about and to document why the system might not be safe, going back to one of the things that we want to achieve. This is also encouraging us to help us in using the safety case to help us to make decisions about what we need to do, because we then need to go out and find ways to mitigate these. It's helping us to identify extra things we might need to do to make the system safe. Okay, so I'm going to go through each of these challenges one at a time, just to show you very briefly the way in which we might go about mitigating these. So we've said that we could potentially challenge this because those weather conditions might not be sufficient. So one of the ways in which we might think about mitigating this is introducing one of these confidence arguments that I talked about earlier. So we can put assurance claim point into the argument at that point. And then we can create a confidence argument to say, why are we confident that these weather conditions are sufficient to get snow? So here we've got our confidence argument. We've got sufficient confidence that a storm from the Pacific combined with cold air from the Arctic will produce snow in Vancouver. And we know that, or we've got confidence in that because we've got data from meteorologists that shows that these conditions produce snow more than 90% of the time over Vancouver. And we've got some evidence for that, which is some meteorological data, for historical data. And also we've observed many cases over recent years of where this has happened and resulted in snow. So again, we can get some data to support that. Okay. And now we can incorporate this back into our safety argument. Okay. We actually don't need this challenge in there anymore. We can get rid of that because we've addressed it. Okay. So we're not addressing this by saying, oh, well, let's put a rebuttal in. Actually, we're changing our argument to reflect the fact that we need to mitigate that challenge. Okay. So we've removed that one and we've added in this assurance claim point. Do a similar thing here. So this was our second challenge about the models not being reliable. So again, we can put a confidence argument in here. So quite often confidence arguments relate to things like processes, because that's how we get trust in, particularly in artifacts that we're using as evidence. So we might have a confidence argument here about the reliability of these models based on things like the processes that we used and why they're good, any tools that we used for creating the models that we trust those, often things like the people and so on. So I haven't put all the details in here, but arguing over these kind of process issues as a way of adding confidence into here. And again, we're adding this into the argument as a way of getting rid of this challenge. So these ones are slightly more complicated. So these are the challenges about changes in wind direction and losing energy. So I think when we look at this and how do we address these, I think this actually forces us to maybe think about restructuring the argument a little bit. And I think we probably need to do something like this. So we've added in a few new claims here. So we change this claim to say there'll be a storm in Vancouver tomorrow, and then we're supporting that with these three subclaims. So the one we already had, which was a storm over the Pacific Ocean predicted to arrive tomorrow. We already had that, but we've now added in these additional claims. So the wind's not going to change direction before tomorrow. And we've gone away and got some evidence for that. So we've got some statistical models of wind direction, and that the storm won't lose energy as it passes over Washington State. And again, we've gone away and got some evidence of that through measuring energy of the storms. And this is a good example, I think, of where we might be forced to go away and get evidence that we didn't previously had in order to do this. So we might realize that if we're going to get rid of those challenges that we had, we have to go and make these claims, need to go and find this evidence, potentially changing what we're doing as a result of this. Okay. So we're now at the point where we've got an argument that's responded to those potential challenges, and we've got something with this extra argument and evidence in it. I think the important thing to note here is that we can't stop challenging. So we've introduced new stuff into here now. We've introduced new argument, new evidence. So we have to think about, can we challenge those? And of course, the answer is potentially yes. Okay, so we've gone away and got this new evidence. So we've got potentially new challenges here. So we've got these new models. So again, we could say, well, how do we know they're up to date, those models? How do we know these measurements that were taken are accurate? And we can imagine that might do some more confidence arguments around why do we trust the models and so on. But one of the other things that I wanted to kind of highlight here is that potentially some of these challenges, we might not actually know whether they're valid challenges or not until the system's actually in operation. Okay, because actually it's based on things that may or may not happen once the system's operating. So one of the other things that we can use these challenges for is potentially as a way of identifying things we need to monitor during operation in order to make sure that our safety case remains valid. Okay, so actually driving monitoring requirements through this challenge to our safety case. Okay. And this leads us into this idea of having a kind of through life safety case. As I've said, helping us to define what we need to monitor once the system's in operation to know that these claims are going to remain valid as things are changing. So essentially what we've got here is predictive post-deployment challenges. So these are challenges that we're making pre-deployment. We don't actually know if there'll be real challenges until we put it into operation. So we're then monitoring for that counter evidence. Okay. And this helps to create what, we talk about through life safety cases. I think something like this starts to move us towards a true through life safety case where it's a live entity. And I guess what I'm saying by that is that the safety case is never really finished. Okay, the safety case has to be continually challenged and continually monitored, even through life, to remain valid. Okay, and therefore it really is a live thing. It's not a piece of paper that gets put on the shelf. Okay, so this idea of using challenges pre-deployment to work out monitoring for the system post-deployment, we've worked up a few ideas around this, and we've got a paper in SafeComp that describes some examples of this, how you can do this for an example for an autonomous system. If you're interested in having a look at more details on that. Okay. Have I got 15 minutes? Yeah, okay. So just one more thing that I'd like to look at. So 6-step method, again, many people have probably seen this. So this is something that's been around a long time now. So it was originally in Professor Kelly's PhD thesis, who I think is coming quite soon, probably. Okay, all right. So this was a method that was put forward to basically how do you create structured arguments, and this is very popular method and works very well. So it's quite a simple, for those of you who haven't maybe seen this before. So creating an argument, 6 very simple steps: identify goals that you need to support. You then define the context that's necessary for those goals. You identify the strategy needed to support those goals, define context for that strategy. You then elaborate that strategy, you go back, identify more goals, and continue around there. Eventually you get to the point where you can get some evidence, and that's your basic solution that you put forward. And I think this has been very successful because it's very simple, people can use it, and this is in the GSN standard as well. So it's been very, very well received over the years. So I wanted to think about, well, how does what I've just talked about, how does that relate to this 6-step method? So this looks very complicated. I'm not suggesting that we add all this on. What I'm trying to show is how this fits onto the existing 6-step method. And I think actually that's relatively easy, because essentially what I'm saying we need to think about doing is at each of these steps, as well as identifying these elements, we need to also identify what the possible challenges might be. So whenever we identify goals, we identify challenges to those goals. When we identify context, what are the possible challenges to that, and so on. Then when we get to step 5, which was about elaborating the strategy and going back to get goals to implement that strategy, I think we need to there just say, well, actually, as well as elaborating the strategy, you need to mitigate those challenges that you've put in as well, which might mean additional goals and additional context and so on. And then when we get to step 6, so identifying our evidence, identifying challenges to that evidence, but then because we've identified challenges to the evidence, we might have to then essentially have an extra loop back here that says, well, now we need to go and find some goals and find some argument to mitigate those challenges to the evidence. Okay, so I think what I've talked about there fits very nicely into current practice and uses current tools that we have. But I think if we can do something like that, potentially we can improve the way things are done and mitigate some of these criticisms that I think we can be open to in the way in which some people currently develop safety cases. Okay, so in conclusion then, so I think we need to, as a community, try and find ways to address the criticisms that are put forward, not necessarily just by arguing against them, but by thinking about, well, can we do something to improve practice to address them? And I think the way to do that is not to try and invent lots of new stuff, but to help people to try and understand how best to use the mechanisms that we already have with things like GSN to try and achieve that. I presented some of my ideas on how we could do that today, using particularly things which are underutilized, I think, at the moment, that are there in the standard: dialectics, confidence arguments, thinking about those relationships. And I'd welcome your thoughts on whether you think that's good or not. But that was all I wanted to say. Thanks.
Thank you, Richard. That's really good. Gosh, makes me think. Yeah. Any questions for Richard? Oh, right. Hang on.
You know who I am anyway. Mark Carter, for everyone else, work for BAE Systems.
Yeah.
Richard, how do you see this? Is it being taken in within industry, or do you still see it as quite a niche type thing that specialists are using and trying to push forward, or is industry embracing this and moving it forward?
I think things like dialectics and ACPs, I haven't seen much evidence of them being used, which I think is surprising because they're now in the standard. And maybe I think it's people don't necessarily know how they're meant to use them, and that's a failing of us as a group that are responsible for maintaining the standard. That I think we need to do a lot more in telling people how to use these properly and how they're meant to be used. And yeah, so I don't think there are people have used the ACPs because they've been around longer, but I've always felt there's a relationship between dialectics and confidence arguments. And I don't think it's been properly explored before what that is. I think this is kind of maybe trying to link the two a bit more, which might help. Yeah.
Thanks very much, Richard. I think that's a really useful example. And as you mentioned, we've been working on doubts and defeaters, and we do actually have a technical report coming out which tries to tie up that transition from doubt to the eliminative argumentation style that you've got. In terms of take up, I think in terms of our ACE platform, it's only recently that we're supporting GSN3, so that's now out. And in terms of industrialization, there are some complexities around needing to keep track of all the negative things that you've addressed, and also the layers of negativity. So there's, I call it slightly pantomime style. Oh yes, you have. Oh no, I haven't. Oh yes, you have. Oh no, I haven't. Yes. And so it could, once you get sort of 4 layers down, it's a bit hard to remember what sort of where you are. But hopefully people will begin to experiment, and maybe we could take that example and package it up for people and that.
So one thing actually, when I was talking about how we don't need that defeater anymore, but actually we want to keep the history of the fact that we had it, so that we can keep traceability, and maybe this idea of having the views, which again is something people have talked about, different views for different people, but maybe you don't want to keep that in the argument unless you choose to have it. And you can say, well, actually show me what those challenges you thought were. Can we put them back in if we want to see them? But we know that they don't need to be there anymore because we've addressed them. So, but again, some of that comes back to tooling and stuff, doesn't it?
Yeah, so I think it's really important to keep that history. But on the other hand, if you keep that, you don't want to see that history all the time because it just clutters things up. So you've got to be able to mark it as addressed, hide it, bring it back. Yeah, all that sort of practical stuff. Yeah.
Yeah, that's exactly what I was going to raise. I wondered what at the end of the day you'd present, for instance, to a regulator, see all of the stuff, but they need to see some of it, surely. And it's trying what level of the detailed argument you'd.
So I think being able to present different views to different people we've talked something we've talked about a lot, and maybe we need to get better at actually doing it.
Okay.
Yeah.
Okay.
Mhm.
Right. Okay. I'll start with the case.
Thanks, Richard. One of the criticisms in Leveson's paper was almost that resources were being taken up on assurance activities and not on the actual safety engineering.
Mhm.
So what do you think are good stopping criteria? Because you could go on with defeating your own claims forever,
Yeah.
but not actually improving the safety engineering of the system itself.
Yeah. Yeah, I mean, you could essentially get an infinite loop where you create a confidence argument to manage a defeater, and then you try and defeat the confidence argument, and then you try and defeat that. And so I think we have to acknowledge that people do have common sense and what we like to call engineering judgment, you know, and that always has to play a role, doesn't it? And thinking about whether continuing forever to think of more and more specific challenges that could be made, whether that's adding value. I mean, I've shown it there in that example, going down one level. I'd say going down at least one level at each layer of decomposition, at least to convince yourself that there's nothing as a minimum, and maybe only going further if you really think that you might get something of value out of it. Yeah.
How do you see GSN being integrated into modern system engineering practices?
You mean like SysML type
Yeah,
stuff?
laptop.
So there is a lot of work through linking into the SACM stuff on creating profiles for GSN. So there's a meta model now for GSN that is an extension of SACM. Yeah. And that allows us to create things like SysML profiles for GSN, which I know from other people involved in the SACM working group, they find really useful as a way of integrating into their tool sets. So these kind of profiles, I think we can create them more easily now we've got the link into SACM. Yeah. And if you're interested in that, I can point you towards some of that profiling work. Yeah. Yeah. Yeah.
Okay. Richard, got one question on the chat from Pravindra. I think he's asking how GSN is used for security arguments. Are there any issues there?
So you can argue about anything in GSN. You make claims about security, and then you create an argument supported by evidence. And GSN is being used widely for security arguments. I focus on safety, and that's why my examples are safety, but
There may be more to, I mean, perhaps
Okay.
the confidence, for instance, is more difficult, isn't it, in security?
confidence is hard anyway. It's hard for safety. Yeah. Yeah.
Yeah.
You know, you can use GSN to make arguments about reliability and not any property really.
Mhm. Okay. Okay.
I mean, I think Nikita's going to talk about security arguments later, so maybe you can ask the question to Nikita instead.
Indeed. So, any further thoughts? Oh yeah, wow, gosh, two more. Okay.
Hi, Ross McMurran, new boy. You teased the paper on and the ability to do post-deployment challenges.
Yeah.
Do you just let us know when that's going to come?
So the conference is in September, so it's embargoed really until then. And it'll be on my website. If you really want a sneak peek, you can ask me and not tell anyone.
Okay, I won't do that.
Okay.
Great. Perhaps one final question. Yeah.
Hi, I'm James Bingham from Atkins.
Right.
Really interested in how you'd link the GSN to residual risks that you'd get from your safety engineering. So the example you gave about there's a 90% chance it would snow in Vancouver kind of implies there's a 10% chance it wouldn't, but the top level claim says it will, which is a yes or no statement.
Yeah. So So, you know, we can make a positive claim here, and then we can say, well, what level of confidence is an acceptable level in the truth of that claim? So we don't necessarily have to have 100% confidence in that claim for this to be acceptable. There'd have to be a judgment that's justified on why that's enough. So we might say, actually, for the purposes of what we're using this for, if we're 90% confident, that's enough for us. Yeah. I mean, I suppose we could change this top claim to be, we are 90% confident that snow in Vancouver tomorrow, and then prove it completely. It's actually just achieving the same thing, I guess. Yeah, but I suppose the key thing there is being explicit about what your acceptance criteria are and justifying those. Yeah, and you could do that with some some context at the top here as well. Yeah.
Okay, thanks.
Yeah.
That's great. Thank you, Richard. I think I better let you go now.
Mhm.
Questions.
Okay. Okay. Thanks.